2024 A-Level Combined Mathematics Paper 1 Part B Question number 17 Part B. Part A of the same question was discussed in a previous video, link in the top right, and Part C of this question will be discussed in a future video, link in the top right. Part B of this question has to do with the sine rule and the cosine rule. The question says, in the triangle ABC shown in the figure here, the BC length is equal to P, the angle BAC is equal to pi by 4 radians as shown here, and the angle ABC is equal to alpha radians as shown here. It also says the point D lies on the extended line BC such that the length CD here is equal to 2p. Now given this information, we are asked to show that the length AB is equal to p times cosine of alpha plus sine of alpha. The question then says, find AD squared in terms of p and alpha, and finally ask us to deduce that if AD length is equal to 3p, then alpha must be equal to the tan inverse of 5. Now to start off with this question, we introduce the diagram and the information given to show that AB is equal to P times cosine of alpha plus sine of alpha. Now in order to do this, we are expected to use the sine rule and cosine rule. Now considering the AB length, we can see the AB length is included in two triangles. One of the triangle is the ABC triangle, which is this triangle right here, and the other triangle is the ADB triangle, which is this triangle right here. Now out of these, in order to find the length AB, we need to find the opposite angle to it and one other side length and its opposite angle using the sine rule. Now considering these two triangles, we can see while both of these triangles have one known side length and AB, only one of them has the opposite angle to the AB length that we want. In this case of ADB triangle, we can see we don't know this angle. However, for the ABC triangle, we can see, since we know this triangle's angle and this angle, we can easily find this angle using the fact that the internal angles of a triangle must sum up to 180 or pi radians. So according to that, if we consider pi by 4 here and alpha here, the angle that is here, the angle ACB, must be equal to pi minus the sum of these two, which is going to be pi minus pi by 4 plus alpha. So according to that, going down, we can say the angle ACB is equal to pi minus the other internal angle, which is pi by 4 plus alpha. And we can say this from the internal angles of the triangle. Now given this, we can see we know the opposite angle to AB, and we also know the length P here and the opposite angle to that, which is pi by 4. Now as we know, when we have something like this, the sine rule says sine of an angle A divided by the opposite length, which is simple A, is equal to the sine of the angle B divided by the opposite length B is also equal to sine of the angle C divided by opposite length C. Now in this case, we only need two of these, and for this we're going to be using A as this angle pi minus pi by 4 plus alpha, and A as the length AB, and we're also going to be using sine B and B here, where capital B is the angle pi by 4 and symbol B is the opposite length, which is P. So considering that if we substitute into this equation, we can see applying sine rule to, and in this case we're applying it to the triangle ABC, so we can say applying it to triangle ABC, we are going to get sine of the angle, which in this case pi minus pi by 4 plus alpha, divided by the length, which in this case is AB length, is equal to, on another side we have the sine of the angle, which in our case is going to be pi by 4 divided by the length, which is P. So therefore we get sine of pi by 4 divided by P. Now rearranging this, we can take this AB to this side, take this P upward, and take the sine of pi by 4 downward, and say that therefore AB is equal to, and if we take the other things to the other side, we can see we get P times sine of pi minus pi by 4 plus alpha divided by the sine of pi by 4. Now considering this, at this point, we are expected to use the identity that whenever you have the sine of pi minus an angle, it is equal to the sine of that angle. So according to that, here we have sine of pi minus pi by 4 plus alpha. According to that, we can replace this with p times the sine of the angle directly, which is pi by 4 plus alpha, and that's divided by the sine of pi by 4. Now what we can do is substitute in the values, and we can see sine of pi by 4 plus alpha can be expanded using the identity sine of a plus b equals sine a cos b plus cos a sine b. So according to that, we're going to get ab equal p times sine of a, which is pi by 4, cos b, which is alpha, plus cosine of pi by 4 sine of alpha divided by sine of pi by 4. Now as we know, the sine and cosine of pi by 4 are both equal to 1 over root 2. That is the reason that the tan of pi by 4 is equal to 1. So according to that, if we substitute here, we can see we're going to get AB equal P times, here we get 1 over root 2 times cosine of alpha plus, and cosine of pi by 4 is also equal to 1 over root 2, so we get 1 over root 2 times sine of alpha divided by 1 over root 2. Now the 1 over root 2 here and 1 over root 2 here and 1 over root here cancel, leaving us with AB equals, and on the other side we have P times, and what's left once we cancel these is simply cosine of alpha plus sine of alpha. So according to that, we can see our answer here is going to be P times cosine of alpha plus sine of alpha. And with that, we are done with the first part of the question. Now moving on to the second part of the question, we are asked to find AD squared in terms of P and alpha. And for this question, we are expected to use the cosine rule. Now expected, of course, doesn't mean it's mandatory, but it's much easier to use the cosine rule to find AD squared in this particular case. Now considering the cosine rule states when you have a triangle with side lengths, let's say A, B and C, and we know one of the angles, in this case I'll mark this angle here, which is capital A, we can say this side length opposite to the angle squared, A squared, is equal to B squared plus C squared minus 2 times B times C times the cosine of the angle opposite to this side length, which is equal to capital A. Now in this case, we can see if we want to find A squared, we know B and C, which are the other two side lengths, and we also need to know the angle opposite to our side length that we want to find. Now considering that, if we want to find AD squared using the cosine rule, we need to know the other two side lengths in our triangle that we're going to be using, and we also need to know the angle opposite to our side length AD. Now considering the side length AD, we can see in this diagram there are two triangles we could use. One of those triangles is the triangle ADC, and the other one is the triangle ADB. Now out of these two triangles, for the first triangle ADC, we can see we know the side length DC, which is equal to 2p. We know this angle, since it's equal to sum of these two angles, pi by 4 plus alpha, but we don't know the length AC. According to that, we'll try the other triangle and see if it's any better. Now considering the other triangle ADB, in this triangle we know this side length, since it's equal to 2p plus p, which is 3p. We know the side length AB because we just found in the previous part of the question, and we also know the opposite angle to AD, since this is just equal to alpha. So according to that, if we apply the cosine rule to the triangle ADB, we can easily find the side length AD. So according to that, let's go down and let's say applying cosine rule to the triangle ABD. Now considering this, we want to find AD, so we can write AD squared equals, and it's equal to the other two side lengths squared added together, which is AB squared plus BD squared minus double the first side length AB times the second side length BD times the cosine of the angle in between them, which in the case of AD, the opposite angle is equal to alpha, and therefore we have cosine of alpha. So therefore AD squared is equal to AB squared plus BD squared minus 2 times AB times BD times the cosine of alpha. Now what we can do is to substitute in the values that we know for AB and BD and simplify this down. Now considering AB is P times cosine of alpha plus sine of alpha. Therefore AB squared would be equal to P squared times cosine of alpha plus sine of alpha whole thing squared. And then we have BD squared. Now BD is equal to 3p because this is equal to 2p, this is equal to p. The total length here is equal to 2p plus p, which is 3p. According to that, BD squared is going to be equal to 3p squared, which is going to be equal to 9 times p squared. And then we have minus 2 times AB times BD, which is going to be 2 times, and AB is equal to p times cosine of alpha plus sine of alpha, and BD is equal to 3 times p, and then we have cosine of alpha. So according to this, AD squared is equal to this expression right here, and with that we have found the length AD squared. Now in our case, we don't actually have to simplify this any further because that's all we need to do in order to complete the last part of the question. Now considering the last part of the question, we are asked to deduce that if AD is equal to 3p, then alpha must be equal to tan inverse of 5. Now considering that what we're going to do here is to take AD equal 3p and substitute it into this expression that we have above. Now considering that if we take AD equal 3p, AD squared is going to be equal to 9p squared. According to that, we have 9p squared equal to, and on the right side we have p squared times cosine of alpha plus sine of alpha squared plus, and then we have 9p squared minus, and we take this thing and this thing, we have 2p times 3p, which is going to be 6p squared times cosine of alpha plus sine of alpha times cosine of alpha. Now considering this thing, we can see we have 9p squared here and 9p squared here, which can cancel, and if we cancel those two out, we're going to be left with 0 on the left hand side and this thing and this on the right hand side. So according to that, we can rearrange this to get p squared cosine of alpha plus sine of alpha squared plus, actually not plus, is minus in this case, minus 6p squared times cosine of alpha plus sine of alpha times cosine of alpha equals 0. Now in this case, since p is not equal to 0, we can cancel p out as well. So we can cancel this p squared out and say because p not equal to 0, p is some positive length. Now given this, we can see we are left with this expression and this expression here. Now in both of these, we can see we have cosine of alpha plus sine of alpha, which we can factorize out. If we factor it out, we can see we are left with cosine of alpha plus sine of alpha times, and factoring out everything else, we can see here we have a factor of cosine of alpha plus sine of alpha, so we can write cosine of alpha plus sine of alpha, but then we have minus 6 times cosine of alpha, so we can have minus 6 cosine of alpha equals 0. Now of course, cosine of alpha plus sine of alpha is never equal to 0. According to that, we can factorize this out and say therefore this term must be equal to 0. So the term here is sine of alpha minus 5 cosine of alpha, which must be equal to 0, and we can say cosine of alpha plus sine of alpha not equal to 0. Now given this, if we rearrange, we can see we get sine of alpha equal 5 cosine of alpha. Dividing both sides, we get sine alpha divided by cos alpha equals 5, tan alpha equals 5, and finally alpha equal tan inverse 5. And the reason we can say this is of course because alpha is in between 0 and pi by 2 radians. So we can say because alpha is in between 0 and pi by 2 radians, if tan alpha equals 5, then alpha must be equal to tan inverse of 5. And with that, we are done with this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you apply the sine rule to triangle ABC and you get the correct equation like this, that gets you 10 marks. After that, when you simplify down and you get sine of pi by 4 plus alpha and expand it using the identity of sine of a plus b, you get another 5 marks. And when you simplify down, cancel out everything else and get ab equal p times cosine of alpha plus sine of alpha, you get another 5 marks. Now after that, when you similarly apply the cosine rule to triangle ABD, you get 5 marks for applying it, you get another 5 marks for substituting the correct values, and after that, when you take AD equal 3p and substitute that in and get 9p squared as AD squared, you get 5 marks. Simplifying this down when you get to this point, and then you say cosine of alpha plus sine of alpha is not equal to 0, meaning that the other term is equal to 0, and get sine of alpha minus 5 cosine of alpha equals 0, you get 5 marks for that. And after that, simplifying down, when you get tan alpha equals 5 and say therefore since alpha is in between 0 and pi by 2, we must have the case that alpha is equal to tangents of 5, you get another 5 marks. And with that, this is the end of this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.